Okay, we want to find f of 5 of x, and this 5 means we want to take the find the fifth derivative. Find the fifth derivative. Is there any reason why we'd find the fifth derivative? I don't know. We're just doing it. We're doing it because we can. Normally, in calculus, we take the first derivative, second derivative, third derivative, and that's usually as far as we go. But this is just a demonstration of taking the fifth derivative. Alright, so we have f of x equal to x sine x plus cosine x. So we're going to take the derivative of x sine x first. Means we're going to use the product rule because we got the product of two separate functions here. Our first function being x and our second being sine x. So the derivative of x is 1, rewriting the second function, plus rewrite the first function, and the derivative of sine x is cosine x. Now we want to take the derivative of cosine x, and that's negative sine x. Then we want to simplify this down. We got some like terms going on. We got sine x and a minus sine x, so they're going to cancel out, and we're left with an x cosine x. Okay, so let's take the derivative of f prime of x. So product again, derivative of x is 1, rewrite cosine x, plus rewriting x, and the derivative of cosine x is negative sine x. And we can't really simplify this down any, except we can take this negative and bring it out front here. So now we're going to find the third derivative. So the derivative of cosine x is minus sine x, and then we're going to be using the product rule here. Now you notice I put a bracket in here, and it's because of this minus sign. Because we're going to end up distributing this minus across, and the bracket is going to help us to remember that. So we start a bracket, and then we take the derivative of what's inside. So the derivative of x is 1, rewriting the second, plus x times the derivative of sine x, which is cosine x. Okay, we distribute this minus across now. So that gives us a negative sine x. And since we can have got some like terms here, we got a minus sine x here, so that's going to give us a minus 2 sine x. And distributing this negative across here, that gives us a minus x cosine x. Now we want to find the fourth derivative. Now you notice I've got 3 primes here. Most of the time I'd put a 3 here, but I got 3 primes. You know, putting another prime is kind of redundant, so we do a little shorter notation, and I'm putting a 4 here instead. Usually I'd put a 3 here, but I don't know. Alright, so we take the derivative of negative 2 sine x, and derivative of negative 2 sine x is going to be negative 2 cosine x, right? Derivative of sine is cosine. And then we're going to use the product rule here again. Now because of this minus sign, we want to make sure that we start with a bracket here. Start with a bracket. Okay, close with a bracket. So the product rule again, derivative of x is 1, rewriting cosine x, plus rewriting the first, times the derivative of cosine x is negative sine x. Then we're going to distribute this negative across and see if we can collect up some like terms. We've got a negative 2 cosine x and a minus cosine x, so some like terms going on here. So we're going to end up joining these two together as negative 3 cosine x, and now we're going to take finally the fifth derivative. So the derivative of negative 3 cosine x is going to be negative 3 times, and the derivative of cosine x is negative sine x, and product rule here. So the derivative of x is 1, rewriting sine x, plus rewrite the first function, which was x, and derivative of sine x is just cosine x. Now you notice I didn't put a parenthesis or a bracket around this guy here, and the reason for that is because it's just a plus sign. But if this were a minus, you want to start with a bracket to help you to remember to distribute that minus across. Alright, and let's see, we've got a negative times a negative, so that makes that a positive. So we have positive 3 sine x plus sine x plus x cosine x. We have some like terms here. We have a coefficient of 3, a coefficient of 1, so we can join those together, and then we just end up rewriting this part. So our final, this is the fifth derivative of f, and our final is 4 sine x plus x cosine x. So hopefully that will help you out on how to take derivatives of higher order.